Only 2 seconds late tonight.
Yeah.
Do it. Just do it.
How about that?
Who's this K2G
Welcome, everybody.
CJB? Who the heck
I
is
don't
that?
know.
What are you
Welcome,
talking about,
everybody, to another edition of Coffee and Ham Radio, where your dreams come true. I'm still getting over this cold, so I'm going to apologize in advance. Literally 5 minutes before I got on here for the show, I was laying in bed doing the woe is me. I'm like, I'm not going to make it. Lord is calling me home. Calling me home.
Take me,
And,
Call his wife, whip him into shape.
Yeah, and then I was just like, well, the people need me. So here we are. Talking about
Apes people.
talking about ham radio stuff, the important stuff, and get you through the day, right?
Was that Sanford and Son, where he's always saying, "Elizabeth, I'm coming."
Yeah.
Elizabeth, I'm coming. I'm
Coming to
coming.
meet you. That's exactly what I was doing.
Wow, 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 wow. Wow, 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 wow.
Well, it looks like Sanford and Son behind this green screen right here. There's so much crap piled up.
That's why we got green screens.
Turn it off.
Both,
Let's see.
both,
Turn it off.
both top ones.
No.
Both tops.
No.
Both top green screens do look like
No.
that, I think.
Nope.
Yeah.
So I've heard.
If anybody's
The
ever got a
slobs
green screen, it
and
means
the
there's a
neat
mess.
guys.
There's a mess. I did some straightening today, but it's still a mess.
Chuck has like a professional background that says I'm a fire guy and I'm a radio guy. And
Let me fix it. Hang on.
it doesn't look all messy now. His wife probably hates it. Oh man!
I hope he doesn't stretch something he shouldn't, reaching back like that.
Good job, Chuck.
Kathy got me some lights for the back. She goes, you need some light back there.
I got to bring my lid in the house. I'm actually working on rearranging all this back here. Mine's hanging out in the shop on the wall. I need to bring mine in too.
You figure one lid would be enough in there,
Right?
That's right.
The lid in the blue shirt.
My helmet.
Gotcha.
Well, you know how Star Trek has their red shirts. Coffee and Ham Radios has their blue shirts.
Right.
It is.
Right.
It is blue tonight, I guess. Yeah.
It's like a dark blue,
Tonight.
navy blue,
It's almost every night it's blue, Jim. Come on.
midnight blue.
Well,
It's like
because
there's like
green-
4 shows in the catalog without you in a blue shirt.
It's because the green doesn't work. Obviously, I got like 3 different green ones. They won't work on this screen. I have a black one, a red one, and a blue one, and maybe 3 shades of blue. I think. I don't know.
I just wear black shirts because they work better with the green screen. So
They're
That's why I
slimming.
wear the dark shirts. I've got orange and gray and khaki
it's my
too.
My Mickey shirt is what I've got on tonight.
His Mickey's. I got my
Apes
beer
all funny.
shirt, too.
I can't go to a ham fest with no Baofeng. People are going to look at me and they think I ain't representing. And he's got his Mickey shirt on.
Right. Well, I used to before people would recognize me. I used to always take my blue or my red Baofeng to the ham fest just to get them upset because people would be like, "Oh, here comes a Baofeng user. Look out! Here Baofeng."
He probably don't know what a balance choke is.
Right.
Probably not.
Exactly right. So today we're talking about random wire antennas, which are end-fed, and they have a Unun at the end of them, and it's a good practice to use a counterpoise and a choke when you use these.
What's
I don't
better,
know
Chuck?
if you boys use those much, but that was when I started getting into HF. I was looking for an antenna that was multi-banded because I'm lazy and I didn't want to have to switch things around. And I wanted to be able to work on more bands. So I ended up with a 9-to-1 was really my first real HF antenna. You guys use them at all?
Use what?
Not
I
really.
got to double it. That's a real antenna.
Shame.
I've had 9. I built a 9-to-1 before we did the Aries. I had a 9-to-1 up for a long time.
Yeah, and there's some misconceptions I think around the 9-to-1s. Like they have pretty good core efficiency, and a lot of times, I like to watch people talk about antennas. That's what I do. And people will be like, they're just not efficient. They're not as efficient as the unfed half wave with the 49-to-1. Big fan of the 49-to-1, obviously. But the thing is that they're actually more efficient in terms of losses in the core. You do less impedance transformation in there, which takes less heat. It takes like energy and heat and all that stuff to do the transformation. So I'm actually a big fan of. When I bought my 9-to-1, I was a little bent out of shape because I set it up, and the thing said you need a tuner to use this, right? I'm like, well, my 7300 got a tuner, son. What up now? I'm in business, but it wouldn't tune a lot of the bands because the
Not a
impedance
big
was
enough
more
tuner.
it wasn't a big enough tuner. So then I had to spend $200 more and get my LDG
200 Mo
Pro 2 100 or whatever it is.
Yeah, those are great tuners too. Those things are awesome.
Yeah, well, so I bought that, and because everybody's like, "Oh, that's the tuner to get, son," and it's only like 65 watts or something like that on digital modes. So I was like, "Man,
digital."
Yeah, because I pretty much just do digital, and then but I run it at about 85 watts all the time, and it hasn't been a problem yet. So that's that. It's in the show. No, so I think we're going to talk a little bit about some examples of these things.
When do you want the ear-chi? Because I have all the tabs ready, but the ear-chi is in the PDF. So
yeah, we'll pull it up in a second. Let me do this. Hopefully, there we go. There's nothing on the table that shouldn't be there, so we're good.
Colin, don't let any old ham hear you say that out loud. You will never hear the end of it.
What do you say?
Son, that's a compromise antenna. Only wire antenna I have ever used is a full-size G5 RV. They work great. Yep. I do use the 993B tuner. No old ham. You got old hams. You got SKs rolling over in their graves. You got people just running to the chat to the comments trying to yell at you right now. I like G5 RVs. I think they're great.
Well, here's the thing, right? So like when people become hams, they want to get an antenna that, just like I was saying, right? They're lazy. They want a multi-banded antenna. They want to put it up and use it and be done with it. Most of the time, new hams don't really understand antennas and how they work, right? So like, well, I got my G5 RV, but I can only get it up 15 feet. And well, you know what I mean? So they start making compromises to the installation, not compromises on the antenna. And because they didn't mount it correctly, they have problems, right? And then they're like, this G5 RV sucks. And then they complain to their ham friends who had the exact same experience, and they all say the same thing. But I've known plenty of knowledgeable folks who think they're fantastic antennas.
What's technically a 20-meter antenna?
It's a 20-meter doublet.
Really good there.
Yep.
Oh, Gray Man's making a comment here that's on point. He's probably right about that. A lot of people bitch about equipment because someone else told them.
I've heard YouTubers do that before.
Yep.
Especially the 991A.
I heard this thing on the news. I need to repeat.
My friend said.
Yeah.
So here's a Digital Rancher.
What's up, Rob?
This is a 9-to-1 that I wrapped, and we'll talk a little bit about. It's nice, right? We'll talk a little bit about the wire that you can use, and we'll talk a little bit about the cores and stuff. But I just really wanted to originally talk about the construction of it. Now, there's more than one way to skin the 9-to-1 cat, but with this one, it's 3 wires, right? So that's called a trifilar winding, and then this one is wrapped 9 times. And there's a little bit of debate as to how many times you need to wrap it, and we're going to talk about that as well. What I wanted to do is show some. I got a picture I'm going to show you, and the reason I wanted to do that is because a lot of people really don't explain how and why these work and how you get to a 9-to-1 impedance transformation. Well, one of the things I will say is that this is an Unun, and it's for connecting unbalanced line like a coaxial cable to an unbalanced antenna like a 9-to-1. Now, somewhere along the line, somebody said you don't need to use counterpoises with 9-to-1 antennas or NFEDs. And the thing is that it's absolute hogwash to say that, because when you have an unbalanced antenna and you're connecting it to an unbalanced transmission line, you're always going to have common mode currents that are coming back on your transmission line, and common mode currents are bad. And a lot of people say things like, well, I want that on there because I want to use my shield of my coaxial cable as my counterpoise. When you run current on a wire, it becomes a radiator. And so the thing is that you are transmitting energy. Now you have to be pretty smart about not having that energy affect your radiation pattern coming off of your antenna, because in your near field, you have all these electrical currents that are moving around, trying to sort themselves out and develop your far field pattern so you can radiate to the person you want to talk to or communicate with. When you have an electrified coaxial cable, that's a pain in the ass. And so that's one reason common mode current's bad. The other thing is a common mode current can mess up your SWR readings. It can give you a shock when you touch your equipment. It can cause computers to act goofy if they're connected to your radio, because that common mode current is seeking a path to ground. So it's always a good idea to use a choke or a Ballon. I'm going to say Ballon choke, but choke, whatever. People get upset
Ballon
about
choke. Ballon choke.
that.
Ballon
After
choke,
this,
Unun. Just put all of
So-
them in there.
right? So you want to go radio, tuner, coaxial cable, choke, Unun, antenna. That's the sequence of how you hook these things up. Does that make sense?
It does, but you went in the backwards direction.
Yeah, I was starting at the radio. I could do it.
I would have gone from antenna and all the
Oh,
way
he's
back
got
to the radio.
drawings. All right.
Yeah.
Oh yeah, he's Mr. Draw. I think he prints these things out in like tins at a time.
I do a printed stack of them out, so that way I have them right here on the bookshelf. And so when we take a look at this, this is a schematic for a 9-to-1. You gotta hide that comment there. And so what we have here is our coaxial cable. And one of the things I want to talk about with Ununs is that this is the shield side, right? So from your coaxial cable, the shield goes to ground, and here's where you would connect your counterpoise.
I knew there was
Over
something
here.
wrong with you, Ape.
What's that? Left-handed.
Freaking lefty.
Oh my
So-
God.
If you take a look at this, if you don't have this counterpoise here, and even with a counterpoise, you're going to get currents back onto the shield of the cable, because we use differential mode current coming out of this coaxial
Chuck
cable
did it
into our
again.
antenna system.
Yeah.
With an Unun,
Sorry.
regardless of the Unun, 9-to-1, 49-to-1, you have a direct path from the antenna to your shield, and that's why common mode current is a problem. If you ever hear anybody who's like, "Hey, I'm an antenna expert. I know what I'm doing. I have an Instagram account. I post on Discord," you don't need to use any kind of choke, and you don't need to use any kind of counterpoise. They don't know what they're talking about, because the way Ununs work is that they have this direct connection to the shield. So when you look at this, each one of these squiggly lines where you have the dot is where they connect, represents one of the wires that we have in our core, right? So we have 3 wires, so we have 3 sets of windings here. In this particular 9-to-1, we use 9 turns. This is the way we do the Aries, right? So each one of these is 9 turns. If you add all 9 of those up, you get 27, right? That's our number. Now, what I want to talk about is that this first 9 here is your primary winding, right? That's your primary. And then your secondary winding is all 27. So that's your secondary. This is your primary. The way that we do the impedance transformation is we take our secondary, we divide it by our primary, and that gives us 3. And then we square that 3, and that
Which
gives us 9.
Yeah.
Right? So that's the 9-to-1. That's how that works. And I just want to share that just so folks understand it. So what you could do, right, is you, instead of doing 9 turns all the way around, you could do 5, right? And that would give you 5 on your primary, 15 on your secondary. That gives you 3, you square it, and you still get 9-to-1. So a lot of people will say, "Oh, well, you have nine wraps on here. That's why it's a 9-to-1." That has nothing to do with it. It's really the impedance ratio that you get when you do that math. So hopefully that helps some folks out. Now,
Is
when
there
we started-
a specific benefit to doing the different amount of wraps? Does it work
Yes.
better? Does it widen out the queue? Does it narrow the queue?
Yeah, so like this one, I think has 1, 2, 3, 4, 5, 6, 7. So this one. So when we were designing the Aries antenna, we did a bunch of testing. So this one has 7 wraps on it. We also tested different cores. Like here's a mix 61. I think this one has 9 wraps, and here's a 43. I think that one still has 7. But we tested different cores and we tested different winding numbers on there. And so a lot of people say, well, the more windings you add, the less efficient your antenna is. And that's true to an extent. And so we actually tested 5 wraps, 7 wraps, and 9 wraps. And I've always used 9 wraps. It's just the way I've always done it from the very first one that I built. You could make an argument that you have better efficiency with 7 wraps, but it's nominal. I mean, it really is not that big of a difference. Like you're talking 2 or 3% efficient difference. And And what I saw is that you don't get as good impedance transformation on a 5 winding. You get better impedance transformation on 7 and 9. I think 9 was the best in terms of impedance transformation. 7 was slightly better in terms of efficiency. So we just went with 9. That's what we like.
So, Ape, our buddy Rob has a question for you. He wants to know, why is it squared? 27 divided by 9 equals 3, squared equals 9 to 1.
Yeah, I'm not sure why, to be honest with you. I'm not going to lie. It's just part of the equation that we use, and it probably has something to do with power, resistance, impedance, and current, and all that kind of stuff.
I think, and I'm not arguing with you because I don't know either, but I think it has something to do with the primary versus secondary. Because if you look at the math for the 49 to 1, it's very similar with, squares and whatnot.
Yeah, well, GOFVT, who is really a bright guy, really appreciate his comments. He's saying it right. The voltage is proportional to the turns ratio, but the impedance is the square of the turns. So there you go. Thank you, sir. Much appreciated. I'll forget that in 5 minutes from now. So I'll have to have you on speed dial for phone a friend next time somebody asks me that.
Right.
My generic, I don't know. I'll try to remember. But
I mean, the goal with any of these things, like the 9 to 1, is to get your impedance to transform from what the end of the wire is to what your radio likes, or what your tuner likes in the case of the 9 to 1. So what was it, 450, Ape? And then we divide that by 9, and then that gets you close to 50. It's not 100% magic, but it makes it easier for your tuner to tune, because now you're inside the range of the tuner, where before you were outside the range of the tuner.
Yes, and he's talking mostly like an internal tuner, 3 to 1.
So
for most 9 to 1 stuff.
Well, I mean, the whole purpose is to do the impedance match, not to make the radio happy necessarily, but to make the whole system as close to 50 ohms impedance as possible.
Which is what your radio wants to hear.
Right. Well, there's two things.
Yeah, I mean, it does, but
you want effective power transfer from your radio through your transmission line into your antenna. And so what this does is it minimizes reflections, right? So you have 50 come in, 450 come out. Hopefully the antenna length that you selected, and we'll talk about that, is close to 450. It's not always ohms of impedance. And then that way you get better, what's called radiation resistance out of your antenna. So think of radiation resistance as kind of the opposite of ohmic resistance. It's the amount of energy that is radiated into the air. And so what you want to do is you want to maximize the power that you're transferring, not lose anything in transmission line, anything in your core, or have anything reflected back and out through the antenna. So it's twofold, right? It's to want to make sure that you have a match system all the way through, but it's for effective power transfer. All right. So with this core and with the areas that we sell, we use this. It's a solid copper core wire. And people say, well, why did you guys end up using the solid copper core wire? The biggest reason is that most of the time when people buy our antennas, they're first-time antenna builders, they're looking for a kit that's easy to assemble, and the solid core wire is easier to wind than stranded copper.
It stays in place better.
Yeah, when I wind, I use stranded copper on my personal antennas. The reason I like stranded copper is that RF travels on the outside of your conductor, not in the center of it. And so by having stranded wire, I maximize my surface area and I maximize current transfer. Is it a big difference? I don't know. But I do that just because it's one more drop of water in the bucket to make everything work a little bit better. But it's not going to kill you. And we use solid core wire on tons of stuff. And I do too. Like on my 49 to 1s, and then the 4 to 1 that Chuck and I were talking about last night. That's solid core wire. There's nothing wrong with that. But I wanted to go into that a little bit because it's a question that folks will ask us often when we test these things. So let me zoom in a little bit more so you guys can see what's doing over here. So you remember from the schematic, I was showing that the ground goes directly to the shield of the connector. So when this little doohickey is here, if you ever buy these connectors, I always use a silver marker to draw on the positive so I can see that because I have bad eyes. So our ground goes straight to the shield. Our 1/3 tap, right? Remember from the schematic, it's tapped at 1/3, goes into the center conductor of our coaxial cable. And then this red is our antenna, our radiating element. And so if I want to mimic an antenna for testing on my nano-VNA, what I'll do is I'll take a resistor that's close in the value that I am expecting on my antenna. This resistor is 470 ohms. It's not 450. Keo kind of already explained the 450. I used a 470 because I didn't have a 450. Now I get that I could hook a bunch of these up in goofy configurations and get to 450, but I'm lazy. And I'll just take the 470 divided by 9 and come up with a number. And if that's what my SWR equals to, then I feel like I'm getting sufficient impedance transformation. Plus, I can use the same resistor against multiple cores and get a relative measurement as to which winding configuration works best.
Now, there is no other way to really test your toroid wrap except to rig up that kind of setup. You can't just slap a meter on your toroid and decide if it's good or bad.
No, and so the reason, and again, you'll see,
because I think I seen somebody, I think I seen a YouTube expert do that and say it was good.
I saw a YouTube expert do that and give advice as to what you should be buying. And the thing is that when you use a multi,
full of crap.
Yeah, when you use a multimeter, you're using DC current. So when we use amateur radio, we use AC current. So you want something that is injecting AC current into your circuit under test, because AC current responds differently at different frequencies. DC current does not. So if you want to test this at a particular frequency, you can't do it with DC current. It just doesn't do it. So in AC resistance is really what we call impedance. And it's made up of ohmic resistance and reactance. And reactance can vary between inductive and capacitive reactance based off of the frequency that you're doing with your AC current. None of that exists in DC. And that's why you don't do that.
So I got a couple, 3 comments here, a question and a comment. Let's see where to go. Here we go. Don.
Look in the starred section.
Yeah, I found it. Don, of course, Don would have a question. Is there any way to make a variable transformer that'll do anything from 1-to-1 to 64-to-1?
Yeah, it's called a tuner, Don.
I was going to say, that sounds like a tuner, is what that is.
Well, what you'll see is that different people will have taps coming off of these in different directions.
At different points, right? Yeah.
Yeah, and they swear that they're fantastic, and they help them grow and be strong and successful. But I don't like it. I just don't like it, because I feel that the more stuff that you have hanging off of this core, the more opportunity you have to introduce reactance into your circuit. And so
it's all going to interact, right? So it's going to change.
Yeah, I'm just not going to do it.
Yeah. Okay.
I mean, you can make a 49-to-1, a 56-to-1, a 64-to-1, and so on and so on and so on by doing those multi-taps. You just gotta tune it, and you gotta understand that it's not going to be perfect, like Abe says. It's good. What's it good for? I don't know, but it's good.
Yeah.
You would think that MFJ would sell a dingus like that specifically.
The 939, yeah.
They probably do have a little black box with a button on the side that you push to go from 60. The most common ones I've seen are ones that do 49-to-1 and 64-to-1, because it's really only another couple turns on your secondary that would do that. Is the black wire the center tap because it's the center of the windings? The answer,
bring out that paper again.
Yeah, is yes. But if you take a look at this, is the black wire right here. It's not the center, right? It's 1/3, and then we have 2/3 in our secondary.
Zoom out a bit.
Yeah. But the answer to that is yes. And then I saw Geo FVT. He's saying that
I'm trying. Quit clicking, son.
I'm not clicking. My hands.
Nobody's clicking.
Some people will test.
My hands are right here.
You have one driving the other one backwards, and so this is that right here. And so we test this way as well. And the first one is, I guess you would call it a step up transformer, and the second one's a step down transformer. So you have 50, 450, 450 back down to 50. But you do get some loss in here. So when I do the back-to-back testing like this, I do it to test core efficiency, and then I do an S21 gain measurement on my nano VNA. So one coming out of the nano VNA, one measuring what's coming in. And I get a value, and I take that value, divide it by 2, because I have 2 cores here. And that gives me an approximation of how much loss I have in my core. And then we can do a little bit of math on that loss to figure out what our percent efficiency rating is.
Casey is asking about the Ferrite clamp.
The answer is yes. So yes, my personal opinion, yeah, like we all put one at the end of the antenna feed point and one at the tuner feed point. So that way we get common mode. on both ends of that cable.
So you can actually be very mathematically specific, and depending on the velocity factor of your wire and the length of the wavelength of the frequency that you're on, you can put the choke somewhere down the middle of the coax so that you get a counterpoise effect with the coax, and then you stop it at the choke point, and then your feed line goes the rest of the way to your radio. But that's really advanced. It's better just to do a real counterpoise.
Yes. Counterpoises are your friend. ABC, always be counterpoising. ABC, always be choking. It's best practice. Now, you can operate without it. It's not going to kill you. You're not going to go to hell for that. But you make it pulling the ham cord. But
right,
it's just a better practice, right? So as hams, we want to squeeze any advantage that we can out of that. And really, a 17 foot of speaker wires or counterpoise costs you 30 cents, right? So just do it. It's not going to kill you. All right. I'm trying to remember what we were going to cover next. Jim, if you want to pull that website up, we can talk a little bit about the antenna lengths.
The Earchi website or the random wire?
Yeah, let's pull up the random wire lengths.
Random wire one? Okay.
Yeah, and then I'm going to go back over here and I'm going to do that.
Let me...
So this is a website that I've been using for years that's super duper handy. And this guy, Jack, he's a VE3. We won't hold being a VE against him. And anyhow, so right.
You talk
he did a lot of
dead people, son. I mean,
he did a lot of work figuring out. So with random wire antennas, you want the antenna element to be a non-resonant length of wire on any ham frequency. So any wire is going to be resonant on some frequency. We want one that's non-resonant on any of them. So like when I was talking earlier about the test that we do with the resistor, a lot of people are like, why do you do that test, son? Because the wire is going to be a different impedance. And they say all the stuff. I just want to make sure that my transformer transforms at the expected rate. And they're like, you can just put your wire up and cut it and test it. I've built tons of random wire antennas. I've never cut one more than once, right? So I cut it, put it up, and I use a tuner to get it where I need it to be. And I use this guy's measurements, because if I start cutting it or messing with it or any of that kind of stuff, I may accidentally make it resonant on a ham frequency somewhere, which I don't want. And so I just go with the estimated lengths that he has here. And one of the things you do need to factor in is the velocity factor of the wire that you're using for your element. So if you have one with a low velocity factor, you might want it a little bit longer than what he says. If you have wire with a high velocity factor, you might want it a little bit shorter than what he says. If you scroll down, he'll start going over. We can link this in the description, but he goes through all the process of how he tested, and him and his buddies standing out in the backyard doing all this rigmarole. And see, here you go. You don't want it to be half wave on any frequency and all this stuff. And he gives a list. There's a table coming up that shows, hey, don't use any of these lengths of wire. We keep going. Nice and easy. There you go.
Do not use these. This will make your spine curl and your hair fall out.
Right. And so what he's saying here at these different frequencies, here are the measurements and the harmonic of those measurements. So you don't want to use any of these numbers. And then if you scroll down a little bit further, here's a whole mess of them. Don't use the green ones. There you go. The green ones are the ones that you want to use. Now, obviously, when you start using like a short one, like 29 or 35 feet, you're going to struggle because you don't have enough copper in the air to really work like 80 and 160 and all that kind of stuff.
Right.
So if you're really going to operate on lower bands, I would use a little bit longer ones. I typically make mine either 35 and a half feet or 41 feet. But I have done 71 feet if I wanted to use lower bands.
And what did you see difference other than the bands? That was about it.
Well, the antenna performs better, right? So
okay.
like I might be able to hear a signal at a 41 footer on 80 meters, but it's going to be faint, right? And it's not going to sound as good as that. If I'm having a 71 foot, I'll hear it a little bit better. The 9-to-1 antennas tend to be a little bit noisy compared to like a dipole antenna or something like that. So that's something else to consider there. And for what we do with the Aries is that we really love the silicon jacketed wire, copper wire from BTEC. But you can use anything you want. Like I in a lot of my antennas I build, I just use speaker wire, and I do that because it's cheap. And if I'm messing around with lots of antennas, because I like to mess around with the antennas for fun. Like I'm not going to build an antenna that's going to be my antenna for the next 5 years. I'm building an antenna that's going to be my next antenna until I find a different one that I want to build. Right. And so if I don't want to spend a lot of money doing that, I'll use the speaker wire.
Now, I was going on here, and this guy did a calculator for doing it to the band edges, as opposed to the middle of the band. And there's a link for it, but I would probably just go with the middle of the band for me. I don't CW, so I did one, and the first one I did, which was, I don't know, randomly a couple 3 months before we released the Aries. I did the 35.5-foot one, and that thing was fire on 12 and 15 meters, just fire, and worked fine on the other bands too. But I didn't try 80 or 160 on it, obviously.
Yeah, and so I said I bought my first 9-to-1 antenna, and some guy just made it, right? So it wasn't. I got it off of eBay. It was the Nelson antennas, and it was a little teeny thing. And if I used it for a long time, it would start to saturate because it's a really small core. And so when your core gets to a certain temperature, it hits its Curry point and loses its ferrous or magnetic properties. Once that happens, it doesn't do impedance transformation anymore. So my SWR was going crazy, and I'm a new ham, so I have no idea what's happening. And I just think my antenna's bad. And I'm thinking I have a loose connection somewhere, and I'm crying, and I'm very upset, and I'm feeling bad about myself. And so I said, well, you know what? I'm mad because I spent $50 on this thing and I have this problem. I'm just going to build my own. And so I scoured the internet and I found the Urchi design. So I don't know if you're going to pull that up, Jim.
Yep. I have to.
It was almost like it was a queue.
Yeah.
Well, he's got a bunch of slides, and I just don't have which order they need to be in. So you just calm down. You calm down.
It's like playing cards with my brother's kids.
Well, look at Jim getting all sensitive.
What? No, I'm not. While I'm getting all
he
sensitive.
doesn't get sensitive.
Never.
You shut up, old man. Tom posted.
He must be looking in a mirror.
Excellent comment in the chat about the squared thing. So
I've got them all starred. Let me pull that up while you're doing that.
Yeah, that's
I'll be a bro.
Kind of yeah, there you go. Bro move.
Yeah, I'm running my yap. I'm not watching the comments at all. But thank you, everybody in the comments, for doing the needful and keeping us going.
The question earlier is, why is the impedance winding ratio squared? And our friend Tom has got a great answer. He says, voltage is proportional to winding ratio in a transformer. Current is also proportional in opposite direction. If wound so voltage is 3x, then current is 1/3 x. For Ohm's law, R equals V divided by I, 3V divided by 1/3 I equals 9x, the resistance compared to the other side of the transformer. So he's doing a bunch of maths there.
Well, it looks more like spelling than math to me, but what do I know?
Well, Tom is smarter than all four of us anyway, so
he is. And you said he's coming back on the show again, right?
I think
he is, yeah.
Bringing him back on the show in a couple weeks.
It's my understanding that Tom sold out of his crowbar circuits after a couple of folks made some videos on them. So
yeah.
And if
should I put mine out? Should I put mine out later then?
Wait till he's back in stock.
Yeah. If you don't have one, you're missing out. Especially if you have a switch and power supply without a built-in crowbar.
And what we've learned is that, like everything else in amateur radio, the crowbar circuit is controversial.
And who knew? I thought it was a good idea.
Right. Well, it doesn't matter what it is. If you advocate anything, there's going to be an upset ham. It's just the way it works.
Right.
So this was what I used to build the first 9-to-1 that I put together. And this says NFED 60 through 40. So keep in mind through 40.
6 through 40.
They go through all the parts that you need, and you can gather these parts. It's a little bit of a pain in the behind. Or you could buy a kit from a bunch of honest people. And then if you scroll down, he goes over the trifilar winding and 9-to-1, unbalanced to unbalanced. And there, does that look familiar? Now, one of the reasons I wanted to share this with everybody was that this is a red toroid we see there, right? So that's a mix. It's a mix 2 powdered iron core. And we're going to talk a little bit more about the different cores that you can use. And a lot of times we see in a lot of antennas are powdered iron cores and not the ferrite cores. And there's different mixes of powdered iron. There's different mixes of ferrite. And you can pick the one that you have. And in a lot of cases, just use any toroids that you have. And people would scavenge these things out of TVs and radios and stuff like that back in the day. And I think part of the powdered iron for these types of antennas is a carryover from the olden days where folks would build their antennas. What I was very surprised about was today I saw a picture of a 49-1 from LDG and it had a powdered iron core in there. So people do use them. They do have their place. I'll typically use powdered irons when I'm building like tuned circuits. So if I'm like making a bandpass filter or a trap for an antenna or something like that, I would use powdered iron. And then for antenna construction, I would always use ferrite. But we've done a lot of testing. So for like our vertical antenna that we're working on, we actually went with a powdered iron core. But I wanted to show this to say, hey, these things can be built on your own for fun, and you can use powdered iron or whatever core that it is that you have. I think he's using a 130 in here. I don't remember exactly. He might tell you in the parts list.
Let's see.
Yeah, 130-2.
130-2.
And so that 130 just means that the diameter of the toroid is 1.3 inches. We're not using any metric system here, son. And that's just the process for that. Now, Jim, I sent you a link for Palomar Engineering.
Yep. The mix selection. Stand by.
Yeah, and the folks at Palomar Engineering are peddlers of ferrite cores and RF solutions, I think is what they say.
Fine ferrite cores.
Fine ferrite cores. Not your Carney level ferrite cores.
Hey, I don't know if you noticed that I posted the specs I got off of ours with different wines on the green toroid.
Oh, you did?
Now, is that big enough for you, or do we need to make it bigger?
How can we?
It's fine.
It'll do.
Oh, Lord.
So different cores perform differently at different frequencies. And there's things that you need to consider, right? Is their ability to operate at those. And it's largely dependent upon heat, but not always, right? And so they go in this list, they talk about different cores, mix, you can see right there, mix 31, 73, 75. And those are the nickel zinc. And then they have other cores that, right? And they talk about the permeability of the cores, but they have a pretty nice chart in here that says, hey, if you're doing this, then maybe this is the core that you should use. And we can drop a link to this as well. And they say that, hey, we sell all these different cores, and this is not all of the cores. There's other cores that are out. Like I just recently did a video on a K-type core for common mode current suppression. But on here, like you see mix 31, and they say right here that it's really used for RFI or EMI common mode suppression anywhere from 1 to 300 megahertz. If you're looking for suppression above that, I think that they say go with a mix 75 core. No, they say 52 or 61, so I stand corrected. So if you're building CMC chokes for UHF, VHF, you may want to take a look at some of the 52s or 61 cores. We actually tested the 61 core for the wideband transformer. So if you look over the column all the way to the right, that has your wideband transformer frequencies. So you could use this to determine what core you want for your project that's appropriate to the needs of the work that you're doing. Generally, I always use mix 31 cores for any balance 1-to-1s or chokes that I'm building. It works great for me. I haven't had any problems, and I haven't had a reason to do anything else. And then if you take a look at wideband transformers in that column, typically we'll use 43s. So we use a 43 on our 9-to-1 and 49-to-1. Those antennas are for 40 through 6. And you can see based off the wideband transformer calculation there, it's perfect for that. And we generally don't have any problems there. Now you could use 52s. And then if you look on their 61s are more expensive. So Gio and I were at Dayton or Xenia or whatever you want to call it. And do you remember the name of the antenna manufacturer that we saw there?
No, I don't. I know we had to like double back because you got yourself all excited. You walked by and like something ticked in your head. those are 61s. I smell 61s.
That I don't remember who it was.
Yeah, and so I was like, well, damn. And I bought a bunch of them, and then I went back the next day and bought more. And but they're expensive, man. I mean, they're good cores. There's no problem with them. They're just expensive. I think they were like 3 times what you can get the 43s for. So I was kind of like, I wanted to get them because I'm a nerd and I like playing around with that stuff. But I don't think that we would tell somebody building an antenna right out of the gate. Like if you're advanced enough to be able to really be able to talk about the nuances between all the other cores, you probably not watching our show, right? And then you're probably not seeking advice. You know which ones to use for the application that you have going on there. But the 43s work really well for Ununs and impedance transformers for most of what we do on amateur radio.
And
so real quick,
go ahead, Steve. Go ahead.
Ham Till It Hurts says, did you see where Yellowstone National Park is hiring 3 radio technicians? Open to the first 150 applicants until January 23rd, or whichever comes first. Government housing may be available. Special working conditions, environmental hazard pay for mountaintop repeater flights and tower climbing. Woohoo! That sounds like fun.
And
that sounds fun up into the tower climbing.
Don't forget the bears. Oh, hell, I don't mind the tower climbing. It's the bears.
The bears.
The other bears. So what I was going to say before Steve got all excited about his next job, I could see you doing that, Steve.
Yeah, I'll do it.
You ain't seeing me climb up nothing. I won't even climb up a ladder to change the light bulb. I'll get the kid across the street to do it.
That's what the kids are for, man.
Hey, man, I got freeloaders that depend on my ability to make an income. If something happens to me,
that's called.
Are you talking about your kids?
That's called your family.
Kids and wife. Right. There was a comment in here.
While you're finding that, I wanted to mention that they give you a bigger breakdown, but basically what Ape said of the different mixes and then what they're available, what form they're available in. And I had a question when we talk about toroids for common mode suppression. How do you feel about beads versus snap-on split versus toroids?
I don't really have a strong opinion that much either way. In the testing that I've done, so I have a beaded choke that I've used, and I use it because it's super handy from a form factor standpoint, but it didn't work as well as a toroid wound and coaxial cable. So I'll leave it at that. You know, what's interesting is a few years ago when I started doing videos about common mode chokes and all this kind of stuff, a lot of people are like, I don't use no choke. I can't see or smell that common mode current. It's not a problem. Now, ABR, who's a friend of the channel, right? ABR Industries, and not just them, but they're all starting to put these chokes on their coaxial cable. So maybe it wasn't such a bad idea anyway. And it's actually starting to become more and more popular just to buy a cable with a choke built in, so you don't have to worry about it.
Well, I don't think it's going to. I don't think it's going to hurt anything, right?
No, it doesn't.
They all work, but I prefer the toroids with the wraps over the slip-on or snap-on or splits.
Yeah, plus the thing is that you can build them pretty cheap, right, as opposed to paying a lot of money for them. Andy was saying he uses 61, that's a comment, 61 cores and bandpass filters. And, it's a good thing to use them for. I use these powdered iron mix 6s, and this is a bandpass filter I made for a show I did with Jim. But the design that I got that from the league said to use those cores. That's the main reason I did it, and not for any particular reason. Here's another one. This was for 20 meters that I put together.
Hang on, let me hold those up again.
Woo, look at that thing.
That is fine looking, son.
Yeah, this is the one I did for 40. It's not as pretty, but I was thinking about actually sticking this back into a Hammond case, like a little aluminum box, and being able to use that one. This one, the 20 meters was just more proof of concept testing and stuff like that.
Whoa.
Just fun stuff,
Let's see. I think we might be out of questions. I believe we are.
All
at
right,
this
so we
time.
talked a little bit. I'm going through my list of stuff that I wanted to cover. Dan in San Diego's got something in here off topic.
That's for them Quartz Fest hippies, the radio hippies out in the desert.
255.
Yeah, you said something the other day about that, Jim. You called it Birmingham, and I thought
Birmingham. That's right.
I thought that was
That's right.
hilarious. I don't know if you were creative enough and came up with that on your own, or
No, I did.
Nah,
I
it's
invented
old.
that. I've never heard it.
It's old.
It's old.
No, Chuck, you're old. That's
Jim is not
Right
sensitive.
there with me, brother.
Birmingham.
All right, you two. Fight it out in the bottom down there.
Yeah, here we go. Michael's saying we need to do. I need to do better because we only have 2 likes so far. What is all of that all about?
Refresh your page, Michael. There's over 43.
Well, we got
Good
100
program, son.
Not to sound like Shane, but we have 192 watch and only 43. That's not a very good impedance ratio.
That's right. And Dan in
it's a
San
lot of
Diego,
loss.
thank you for being a member, son. We truly appreciate it.
So, I guess
This,
what I could do
this is a
just
big
do-
no. Did you guys say no to this already? Not until I get back.
They ain't going to
We
ship
didn't
because
say.
Chuck ain't there. But
Yeah.
Kathy, who's the head of our shipping department, said that nothing was shipping after Friday. When are you getting in the box and going down the road?
I'm leaving tomorrow. So if it's here
So
tonight,
nothing shipping after right
if
now.
it's in tonight, it'll ship tomorrow.
All right.
oh really? That's assuming I go sit here on the website all night looking at stuff. If
Well, I
you
mean,
get it in
well,
before
I
10
wouldn't-
o'clock,
watch Star Trek.
if you get it in before, no, your mom's calling me after the show.
Yeah, right.
If you get it in before 10 o'clock, it can go out tomorrow. If it's past 10 p.m., you're out of luck.
10 p.m. Alabama time.
Central time. That's right.
Thank you very much, Andy, member for 20 months. And we got a controversial
Andy.
one here from Jason. Thank you, gentlemen, and Jim.
Thank you, Jason. I appreciate it. Somebody's
Yeah,
got to
thank
keep this show on track, son.
Well, thank you.
Bill, you got
There's
to
a
press
bunch
it odd numbers of times, not even numbers of times.
That 7.255 is a busy frequency. Just saying.
Dan was saying that's the Quartz Fest Nevis.
Oh, really? That's
what
the
you were
guys
saying.
in
On
San
the ground
Diego.
and get
The guys
after
in
it.
San Diego that I talked to. That's where they're at all the
Ooh.
time.
My man,
Cliff. Thank you,
Hey,
Cliff.
Cliff. Thanks.
Cliff,
Thank
thank
you,
you, brother.
Cliff.
Nice.
Appreciate it.
I feel like she's going to get
He's always
arthritis.
watching. He's a good guy. So we still have a little bit of time left, so I guess we'll do this real quick. This is my Nano VNA H4 that I love, and so here are
H4.
the back-to-back cores that we were talking about earlier. And so this is channel 0. Sometimes it's called port 0. Nano VNAs call them different things, and we squirt a signal out there, and it goes through all this mess, and then we get a signal in here. And what the Nano VNA does is it compares the output to the input, and it comes up with a loss number. And we mentioned earlier that we divide this loss by 2, right? Because we have 2 cores. So if I do this, hopefully I can do it right. Give me 1 second, boys, because I'm a little bit of a dumbass.
I mean, it's not like we're live. It's okay.
Just a little bit.
Well, son, I'm talking too, man. You know what I'm saying? I'm trying to do the needful.
Glad this show was on toroids and not on the roids they usually talk about on 80 meters. Doc Brad, that is
Doc, you
correct.
Thanks,
so
Doc.
right, my friend. Doc,
Right.
appreciate it, buddy.
She wants to talk about roids.
All right.
She
Can
can
y'all
talk
see
about
that?
anything she wants. Yeah. I mean, other than your big head's covering half the screen, but
There you go.
Well, we can see the screen you're sharing that I just put up. Yes.
All right, there we go. So what
Come on,
that
Randy.
is this is Nano VNA Saver, and we're just going to do a quick sweep from 6.5 megahertz to 30 megahertz. And let me hit the sweep button. I have it set for 10 segments just so it can be a little bit more granular, but it's probably not necessary. And this is just cores that we messed with. This isn't any core that we're selling or anything like that, but it's kind of how we do our testing. So marker number 1, which is right here in the 40-meter band, if I come up and look at my table for marker number 1, I can see my S21 gain measurement is negative 2.9. And that means I have almost 3 dB of loss. And we all know 3 dB is half my power, right? It gets better as it goes up. So if I was using these cores and I was going to do it maybe in the 10-meter band, then I think I would be fine. But because I like to operate on 40 all the time, this core is not good for that. So we might say, well, what the heck is negative 2.9 dB in loss? What exactly does that mean? And remember, we also have to divide this by 2. So let me go back to stopping sharing in the window here. And then let me open up my handy dandy calculator that I love so much. And I can actually share that, or we just do that.
Yeah. That's right.
So this is my scientific calculator. Everybody has one that come free on your computer. So there's no reason not to learn how to do this. If I clear this out, right? And so I take my 2.9, right? And so I say 2.9 and I divide that by 2 because I have 2 cores. So I'm really getting about 1.45 dB of loss in a core. And so I say, well, what exactly does that mean? So let me clear this out a little bit. And I want to put a parenthesis in there. I want to go negative 1 point, I think it was 4.5.
Yeah.
Right.
Yep.
And then I want to divide this by 10. And I want to close my parentheses. And then I'm going to come over here and use this 10x. I'm going to hit that and boom. And so what that's telling me is that the core at that frequency is 71.6% efficient. So if we're putting 100 watts in there, only 71.6 watts are coming out. And you say, well, what's happening to those watts? You know, there's 29, 28 and a half watts. They're heating that core up and getting it towards its Curry temperature, right? And so you're incurring loss there, which is a bad thing. I think that's the end of the product demonstration.
Very good.
I think it's just handy. Like if you get into building antennas, and with us, with like the antennas that we build, we want to share all that information, right? So people know what they're getting, how we derive to the performance, and why we, talk shit on our antennas being so good. It's because we actually do.
Because we try.
We do a lot of that testing. And then that was just our 9-to-1. I think you can use these instructions. They're pretty handy. If you go down, I was showing the wrapping that we use, the winding that we use to get to the 9-to-1.
Right
and
there.
What's funny is that some mouth breather stole that graphic that I made. So I made that graphic in Canva, and somebody stole it and they erased the logo and put their own logo in there.
That was bad.
And some turd.
Are you talking about this one or the other one?
That one right there. Well, it was the one that had, because originally when I did it, it was before we made this antenna. It had the Smoke at Ape logo in there.
Yeah, because I carefully took that out and put the Coffee and Ham Radio's logo in it.
Yeah,
are you talking about me?
No, it wasn't you. So somebody was posting it. They're like, hey, I'm selling cores or whatever, and that's the image that they use for how to wind it for their kit, and it had their call sign in the middle of that.
Oh, he just went. Did you hear that accent, T.O.? It's getting stronger.
Oh, he's getting all emotional. Like he's getting sensitive.
I'd like to run into that guy at the pork chop stand in Dayton, and I'm just like, come on, man, have a little bit of decency and redraw it yourself.
I mean, like I did.
And that's Chuck's hand holding that Toblerone.
Is that Chuck? I thought that hand is a little chunkier than yours.
Yeah, it ain't mine.
You got them skinny fingers, eh?
They need to be nimble for typing on the keyboard all day.
That's right.
Lithe.
Chuck
that wasn't with a lisp. That I'm saying lithe.
So since we're talking about cartenas right now at this time, and we got about 7 minutes left, 6.5 minutes left. Why do we not do our antenna with an SO connector? Why do we use a BNC instead of an SO?
We argued about that a lot at first, and one of the reasons is the BNC is a little bit smaller, so it's easier to fit on there. But for whatever reason, I was under the impression, and I think I still am, that portable antennas generally have BNC connectors on them.
Portable and QRP comes with BNC, and it is kind of an argument. A BNC connector is capable of 100 watts, just like your SO239 PL259 combo is. Just people just associate it that way. And it's just easier to put on our antennas. They're smaller. They take up less space. Not they just as good as every other one. They just different.
Right.
And honestly, you can't be a real ham unless you have a box full of random adapters, except the one you want today, which you have to order from Amazon, and then you find the bag of those that you bought 3 weeks ago from Amazon.
I've done that many
Right.
a time. And then Graybeard Poda is saying, where can you find project boxes? So he and I were talking earlier. If you're talking about project boxes for the bandpass filters, you can get them off of AliExpress, but that's not going to meet your deadline. And I got ham shamed for using one off of AliExpress because somebody was like, their legitimate Hammond boxes are made in America.
What size box do you need?
It's like, I don't know. It's aluminum box. It's like 2.5.
Oh, the aluminum boxes?
Yeah, but you can get them off of Tube Depot, TUBE Depot, and those Hammond boxes are made for guitar. Sometimes they're called stomp boxes.
Mm-hmm.
They're made for guitarists that would build in their own pedals, and so you might be able to find someone there if that's what you're talking about. If you're talking about casing for an antenna, just go on Amazon and look at them, or you can find electrical junction boxes at like Home Depot. But they're for bigger cores and stuff like that.
Hey Bryant, that's the ape. This is T.O.
What happened? we got a miscommunication here.
He's trying to tell me that they're called guitar pedal boxes. I was like, I was silent the whole time. I don't know what you guys leave me out of this one.
Well, I'm fine with him telling you to stay in your lane. Guitar pedal box. Yes, I've heard them called stomp boxes. But I think the manufacturer is called Hammond, Hammond.
And you could use junction boxes too that you can get.
Ain't no bud boxes here. They're light boxes.
Home Depot.
So I was trying to find the ones I ordered because I thought I got those off of Amazon, but it's not coming up.
Yeah, I don't know. I get a lot of them off of Amazon, but a lot of times I order them and then they're little bit wrong size in one direction or another, and I get all mad and have to order another one
because you were too lazy to measure it the first time.
Well, the thing is like, you can't just measure the tow rod because you got wires running around in there and posts and all that other stuff.
When we did those,
Brian, we're just having fun.
When we made those RF taps, God Almighty Jesus, I ordered those small boxes. And get the bulkhead connector to fit in that thing was just a little. The inside of the box was curved, and that you couldn't get it to fit flush. I ended up using the junction box.
This is one of the Hammond boxes that we were talking about, and I put these.
That's nice looking.
Well, professional. I got to keep up a certain level.
I found mine, so I'll put a link to it.
And there's just some parts.
It does support the channel too, guys.
But the idea behind this bandpass filter, I just put these connectors on here for testing, is that it will fit in this box. See, and then I can push it down in there, and then mount it in this housing, and then that way it's a little bit more durable. But that's a Hammond box. I wouldn't do any antenna in this box.
Here's the one I just posted. If that's big enough for him.
Ed just that's it. Ed just posted the link for I couldn't remember the name. The Carlin, the 4x4x2 is a really, really popular box. But good luck with it being in stock.
4.5's got a question for you.
Will you design a
waterproof? We don't need to know what it is.
We might. We just haven't. We just haven't done it. But we can put.
Because the first thing we're going to do with a waterproof box is drill holes in it.
Yeah, which kind of. I mean, yeah.
Well, mine's 1.5 by 2.5.
Too. It doesn't necessarily need
to
be
4 3/4
waterproof.
Well, I mean, talk to Don. He leaves his car tent out in the rain all year round, and it's been fine.
Yeah,
we don't advocate for it, but what's going to hurt? It's just going to get dirty.
I mean, you could flex seal it too, right? And so
in the spray can, that's right.
Yeah, Chuck, mine's the same size. In that article that we were using earlier, Tim, that has the Hammond part number in there. And then you fill the box with paraffin wax. I do not. People talk about putting goofy things in there, wax being one of them. Another one would be oil. So that does help pull heat away. But also, if that stuff that you have in your box hits that temperature that's bad, it's going to take longer to dissipate too. So no, I don't do it.
Insulation works both ways, friends.
Right.
Yeah. All right. We're at 60.
It was. I'm assuming Kyle's going to be streaming something about.
He is. Kyle is at 8 o'clock. tonight.
APRS Thursdays, yeah.
APRS Thursday. Yep.
So we want to be cognizant and aware.
Yep.
Yeah. Thanks, everybody. Had a really good time.
Make sure you tell them we sent you, though,
Yeah. You tell him
Right.
Coffee and Ham Radio. That's right.
since we're carrying him.
The premier amateur radio show on YouTube.
Where we talk about radio every show.
Mhm.
Right.
Some kind
I'm
of
hitting
radio.
the button. Say
You're
bye.
hitting the button.
Later, everybody.